The diagram below represents a cuboid ABCDEFGH with a square base ABCD. The diagram is there. Given that AB is equals to 6 centimeters and AH is equals to 10 centimeters, calculate the angle between the planes ABCD and EAC. That is the angle between two planes. The first thing will be to draw the plane EAC so that it can be visible, and I'll draw it. So plane EAC, we already have the base ABCD, so EAC is here. So that is the plane EAC. Now you can see clearly the two planes ABCD and EAC. Now how do we get the angle between the two planes? We do this by looking at the line of intersection of the two planes. So the line of intersection of the two planes is AC. So we draw a perpendicular to that point of intersection. First we'll have to create the center, or the center of the base. You can assume the center. Let the center be there, and we call that center O. So we draw a perpendicular from point E, that is on this plane EAC, to that line of intersection. So we'll draw that perpendicular. Then from the other plane ABCD, we draw a perpendicular from point D to intersect the other perpendicular or normal. So from this point D on this plane ABCD, we draw perpendicular there, that is the other perpendicular, are still meeting at the line of intersection, that is AC. And now the required angle will be the angle between the two perpendiculars, or the two normals. The first perpendicular was in plane EAC, so we drop that perpendicular from point E to the center of this line of intersection of the two planes, that is AC. The second one, from the plane ABCD, we drop a perpendicular from point D to the center of the line of intersection where the two perpendiculars are meeting. The angle that is formed there, that is the required angle. So this is the angle that is required, that is here. So we'll need to complete this, we need to complete that triangle, that it can be visible very well. So this is a triangle. So I want you to look at triangle EDO. I will extract it here, that you can see it clearly. So there we have point D is here, then O, which is here, then E is there. So when you look at that triangle, that is a right angle triangle, and the required angle, you notice the required angle is this, the angle between the two normals, or the two perpendiculars that you drew. So the only side that we know is ED, which is 10 centimeters. So we need to get at least another side. When you look at EO and DO, the easiest side to get is DO. Why DO? Because DO, knowing very well that ABCD is a square, that is a square base, we should know that AO is equivalent to DO. So when we calculate AO, we automatically get DO, because AO is equivalent to DO. And how do we get AO? AO will be given by a half of AC, and it is very easy to get AC. AC, we just need to use this right angle triangle here, ABC, and use Pythagoras theorem. So AC will be given by the square root of Pythagoras theorem. This is 6 squared plus 6 squared, and this one will give the square root of 72. The square root of 72, 8.4. This is 8.485 centimeters. So that is what you get. So already we have that AC. So now getting AO will be easy. So AO we said AO is equals to half of AC, so this would be given by a half of AC is 8.485, and these would give, so we just need to get half of that, so 8.485, we divide that by 2, we get 4.243 centimeters. So AO is that, and remember we said that AO is equals to DO, so DO also will be given by that, 4.243 centimeters. So this will be 4.243 centimeters. Now the triangle is complete. Now we can use trigonometric ratios to get that angle. So that angle theta will be given by, we use tan. So tan of that angle would be given by opposite, which is 10, over the adjacent, which is 4.243. So theta would be given by, we get the tan inverse of 10 divided by 4.243, and this will give, when you get the tan inverse of this, you get 67.01 degrees, and that is how we get the angle between those two planes.